Well, hello everyone, and welcome back to Adrian's Digital Basement 2. It's a super mini mail call. Before we get to the packages, I just want to say hello and thank you to everyone I got to meet at the Seattle ICF. That's the Interim Computer Festival. By the time you're watching this video, I will have just gotten back from that event, and it was a total blast. The event is a lot like a miniature VCF. It's very small compared to, say, VCF Midwest, but it's a nice local gathering of people from the Pacific Northwest who like to show off their stuff and socialize and just have a good time. At the event, I got to meet a bunch of viewers that came to say hello, including a few that gave me a few things to bring home with me. And we're going to look at those things today. I'm going to count them as little mini mail call items. I also got a chance to drive Postal Dog's Grumman LLV, which is in the United States known as the mail delivery van for the USPS. There are very few of those that are in private ownership, but this one is, and it's been swapped with a V6 engine from a Chevy S10, and it was a total blast to drive. I was literally grinning the entire time. Anyhow, let's take a look at the stuff that I brought back from the trip. Just a couple items. So the first thing here comes from Jerry. And unfortunately, I'm not going to be able to demonstrate this. And that's because the firmware that's on here, and this is an ESP32, is hard-coded to Jerry's network at home, so I can't easily use that. So Jerry said he will send me some new firmware to flash onto this ESP32 so I can use this. But what this is an open source project called Flying Rommy. You can see it's written there. There is a GitHub repo. I don't have the URL for that right now, but I will put that down in the description so you can take a look at this yourself. This is a ROM emulator. The initial goal for this project was to make something that you could pop into your Commander X16 and program on the fly, obviously via a web interface. So if you're working on firmware development, and say you install some bad firmware into your X16 and it no longer boots, you just take the chip out of the board, program it in a programmer, put it back in, etc., etc. The Commander 16 and the Otter, which is the other alternate version of the Commander X16, both can program the ROM chip in situ, so on the board. Problem is, if you screw up the ROM, like say you corrupt it or whatever, then you can't run the programming software to do that. So I love the idea of a project like this where even if the system is not booting, you can still get to the web interface on the ESP32 and load new code into the ROM and then reboot the system. Now I think what Jerry was telling me is that this uses SRAM. There's an SRAM chip on the little board on the bottom here. And when the system boots and powers up this whole assembly, the ESP32 will load the SRAM with the contents of your ROM, and in combination with a little reset line will reboot your system that this is plugged into, and then it will start executing the ROM code out of the SRAM. Now you might be thinking, well, how can I use this on something else? You know, this part number here is obviously used on modern stuff. I don't remember how big this is. The ROM is quite large on the Commander X16. I printed out the pinout for the 27256. Say this is a very common EPROM used on, say, IBM PCs for BIOS ROMs. Notice that pretty much everything is identical all the way up to address line 12, and then VPP is just normally 5 volts on these chips, because that's only used for programming. So if you're creating an adapter to use this in something like a 27256 socket, it's really easy. You just pass through all of these signals from A12, pin 4, all the way to pin 16, and then you just need to, well, you can ignore actually pin 1, that's not even used. And looking on the other side, it is exactly the same thing. All of this stuff is exactly the same all the way up to address line 14. And the only pin that you'll have to remap, so to speak, is the VCC pin. Luckily, this chip, the one that this is designed to replicate, is just so similar to the pinout of all of these EPROMs that it's going to be easy to adapt. I have shown another EPROM emulator on the channel before, and it works in a similar way to this, although I think it actually is a little bit more flexible about reassigning the pins so it can dynamically emulate different types of ROMs. I'll link to that video in the description below, but this one with the right firmware, once I can get it connected to my Wi-Fi network, and then an adapter which I could just make very easily, and then I'm off to the races. We can do all sorts of different development work with this. Now, of course, there are extra things that would be nice to be able to use. For instance, if you have a motherboard that has 2 ROM sockets with 2 different chip select lines, you know, say for an odd and an even, well, it'd be pretty handy if we could just use one of the unused pins on this to connect to the chip select line on the other socket. So you can just plug this into one of the sockets via an adapter, pick up that signal off the other socket, take both ROM chips off the motherboard, and then this would work in place of the 2 ROM chips, like 2 of the 27256s. So anyhow, once Jerry gets me the new firmware so I can flash the ESP32, get it on my Wi-Fi network, I'll definitely do another quick mail call episode showing this off. As I mentioned, I'll link to Jerry's GitHub repo with this project, and I haven't seen the license agreement because I haven't looked at the GitHub repo yet. I don't have the URL, but if it is amenable to it, maybe some derivatives can be made, different versions, like a version that plugs directly into the C64 motherboard that allows you to swap the kernel using a web interface. That seems like a really cool project and a cool idea. So thank you, Jerry, for giving me one of these. I'm looking forward to trying it out. And Jerry is one of my patrons, so thank you again for being a supporter as well. Okay, next up we have something from Brad Bell. And Brad has given many things to the channel over the years, including this card here, which is the SmartDisk II. This is an Apple II open source project that replicates the Apple II disk controller, hence the two connectors there that go to the drive 1, drive 2. But what this adds is the soft SP ROM. So what this gives this card the ability to do is work with SmartPort devices as well. Now, what's a SmartPort device? Now, this is a floppy EMU. This can emulate a SmartPort device. SmartPort is like a packetized protocol that runs over the disk-to interface, and Apple designed it to allow for things like hard drives to connect up to the computer. SmartPort support is built into the Apple IIc and the Apple II GS, so you can just plug things like this directly into it and boot hard drive images. There are other open source projects that support the protocol, like of course FujiNet, which I've demoed briefly, a prototype version of the Apple II version, but I'm pretty sure there's a full version out now for FujiNet for Apple II, and that uses SmartPort protocol to not only handle hard drives, disk images, but also you can run like CPM over the SmartPort protocol. You can connect to BBSs and serial connections over the SmartPort. There are all sorts of capabilities that FujiNet adds or does with SmartPort, things that it always supported but were just never used. So FujiNet should work with this card from Brad as well. And then there are other SmartPort projects that are open source, like a little hard drive emulator. I think I have one upstairs plugged into my Apple II Plus, and that allows it to easily boot hard drive images. And of course, it's open source using Arduino, so it's very cheap to build. It's less expensive than the floppy EMU, which is not open source. Now, what Brad handed me when I saw him in Seattle, and Brad lives up in Seattle, is a replica of the Apple Super Serial Card. So this project, which is open source, there's the GitHub URL, is fully available to build for anyone. The PCB is very small, so it fits within the cheap PCB prices. 2 footprints for the crystal oscillator, and all of the chips that are on here are easily available. There are no PALs on here, no GALs, just a single EPROM, and it completely replicates the functionality, and I'm going to grab it here, of the original Apple Super Serial Card. Now what this card does is it just adds a serial port to your Apple II, and Brad obviously did away with the dip switches and this block here, which I think he flipped this around and it basically gives you a null modem cable, equivalent of a null modem cable. So that's gone. Dip switches are gone, which I don't think anyone really uses. I can't remember what these even do, and the fact that they're not on here I don't think poses a problem. But these cards now are, well, they were really common back in the day, but I think they're becoming kind of expensive. So this project allows you to get a serial port on your Apple II without spending a whole bunch of money. Now, one of the big reasons why you'd want to add a serial port to your Apple II is mainly for ADT Pro. With another computer with a serial port, say an old laptop or whatever, anything with a USB serial port, and something like this on your Apple II, you can send disk images into your Apple II and create Apple II floppy disks. Making Apple II floppy disks hasn't always been the easiest thing in the world. It's actually a lot easier now. We have Greaseweasel, an open source disk imaging product that allows you to create Apple II disks natively on a modern computer. But before that, it was very difficult to do. So ADT Pro was one of the only ways to really reliably image Apple II disks, either read them and copy them into a computer or create disks. And that was one of the big reasons for having one of these super serial cards. Of course, you might also want to connect to Telnet PBSs and stuff like that. Now, this little serial port cable that is on the original card does work on Brad's card. But what Brad has also done is recreated this, which is the slot bracket for the Apple II and the Apple II Plus. These are not super common. I have a few of these, but I have a lot more Apple II Plus and II machines where this cable just sort of hangs out the back like this, which is very typical. It's how most people did it. But the bracket that was on a lot of the original cards that Apple sold looked just like this, and this actually kind of slides down into the back of the computer and then gives you a nice firm connection for your port. It does unfortunately scratch up the case, and that's just sort of par for the course with the way this works. So if you're scared about doing that or it's not already scratched, then I wouldn't advise using these. Now, to get these made, you use Send, Cut, Send, I think the service is. It's a local service in the US at least that can fold and cut metal. And of course, the project files for this are fully available, and Brad told me there's a version that has 2 9-pin connectors as well. The 9-pin version can be useful if you say just want to have a 9-pin serial port and say you want to have an external joystick connector for your Apple II Plus. There, you can make a little cable that plugs into the joystick port, which is a little dip IC socket, and then goes to a normal 9-pin port that has the same pin out as the Apple IIe, 2C, 2GS, stuff like that. So pretty cool. I've never seen anyone having replicas of these, and of course, like I said, you can get them made yourself at Send, Cut, Send. How freaking cool is that? Now let's take a quick look at the GitHub repo for the Super Serial card. Of course, this is fully open source and available for anyone to download and make yourself. So the EPROM that's used on here is a 2716, and that replaces the PROM or EPROM that was on the original Apple card. For the ACIA, which I think is Asynchronous Communication Interface Adapter, I think that's what that stands for. You can use an old MOS 6551 or equivalent, and the WDC 65C51 has a well-known bug that likely makes it unsuitable for some uses, although it may be fine for others. The chip that's on here is the 65C51, but it's made by Rockwell, so I think it's an old part that probably came from AliExpress or whatnot. So I totally recommend looking around, just finding an old source for these chips if you're going to build one of these up yourself. Brad mentions how to make the original cable. And then you do have to find the RS-232 driver and receivers. That's an MC1488 and MC1489. These are super common chips that were used on all sorts of things, including the Plexus sitting behind me. It uses these 2 exact chips, the Motorola parts. But there are other equivalents you can use as outlined here. You can reconfigure the card to be either modem or terminal mode, depending on, well, it's kind of the same as this block that was on the original card, but you have to use these little jumper links to do it. That's right, and the dip switches that were on the original cards kind of set up the default settings for the card, but they can be overridden with software, which I know ADT Pro does. And it's funny, Brad says, if you commonly used to use these cards for more than one purpose, like you had to switch the switches periodically, it's probably best now just to make more than one of these cards because they're going to be so cheap. And then moving on to the brackets, these are those rear IO clamp clones that you can download the files for and have them made at Send, Cut, Send. Now, Brad has a bunch of other projects as well. We'll look at those just quickly in a second, but it looks like one I hadn't heard about was an NES controller adapter interface for the Apple II. So this replaces the PCB in the controller itself. That seems like a pretty cool project. Although, I think for me personally, I would much rather have an adapter that goes from the NES shift register type joystick ports over to, say, Apple II or IBM PC without having to take the controller apart. So you could just plug something in between the cable and have that conversion done. That would be the ultimate thing for me, because I've modified one of my NES controllers for Commodore 64 use, so it's just a digital TTL, but I didn't really have to change anything internal to the controller because I just wired directly onto the shift register inputs and ran a cable with a 9-pin connector on it, so I could revert that back to an NES controller. Obviously, swapping out the PCB also doesn't permanently modify anything. You could just switch back to the original Nintendo PCB at any time. But on the other hand, you have to be very careful when you replace the PCB, because if you don't use gold contacts for the button contacts, you're gonna have a joystick that does not work reliably. Especially if you don't use it very frequently, you might put it aside, use it a year later, and you'll find the button response is terrible. Now back over on GitHub, let's take a look at Brad's other projects. So of course there is a Disc2 controller replica. So this is different than the SmartPort one, which I was talking about earlier in the video. This one is absolutely just a normal Apple II disc controller replica. So if you don't have one of those, I don't know how expensive they've gotten these days. The original Apple II controller uses PROMs, programmable ROM chips. This just uses 2 EPROMs, and I've used these. They work absolutely perfectly. Here's the repo for the original SmartDisc2. Oh, and I meant to mention earlier that the card that Apple released for SmartPort for the Apple II Plus, 2, and 2E uses the integrated WAS machine chip. This card is known as the Lyran, and they're super duper expensive. Now you can make a clone of one of those, but you'd have to take that integrated WAS machine chip out of a Macintosh or a 2C or whatever, another machine that uses that same chip. So this project is cool because it doesn't use any of that stuff. This is just using completely off-the-shelf parts. There's nothing custom Apple. And that means it's very easy and cheap to make. And that's what's so awesome about it. Now this card is not really designed to be a Disk-II controller. It's designed to go in your computer in addition to a Disk-II controller, and you would plug your SmartPort devices into this as opposed to regular floppy drives. Now it looks like there's experimental support for Disk-IIs, but ultimately I would actually just recommend that you use the regular Disk-II controller in like slot 6, put this into slot 7 or slot 5 for your hard drive emulation. Brad also has a very easy to assemble language card. This is the switchable version. It has the ROM socket on it that I talked about. So you could switch to like a RAM test or switch it back and it would just go back to normal AppleSoft Basic. Or if you wanted to have integer basic in a ROM, you could do that as well on your 2 Plus. This is based on my friend Frank's IZ8DWF's design, but the Frank's was all surface mount. Also available if you are happy building surface mount, but if you like dip stuff, then this is a really great solution. And of course, all the PCBs that Brad designed are very small, so they're very easy to make and very cheap to make from any of the PCB services. Brad also released a VIDX compatible 80 column card. These are getting more expensive these days, even though there were so many clones of these back in the day, like identical clones. But here's one you can just make yourself, all off-the-shelf parts again. I think it's a 6845 or is it 6545. The CRTC is probably the one thing that's not something you might just have lying around in your box of parts. But everything else on here is like normal SRAM and just a bunch of TTL logic and a couple ROM chips. All pretty easy stuff, so simple to make. There's also a clone of the Grappler Graphic Plus parallel printer card, and I think Brad might have done this one because originally the way to use the SmartPort disk emulation, that's for this card, you used soft SP-ROM on a Grappler card, and then that would allow you to actually, well, it would no longer really work as a parallel card, but it would allow you to do SmartPort with a normal Disk-II controller card. But that required 2 separate cards, and it wasn't ideal. But I think this is just the recreation of that card. So if you want to have a parallel printer card and don't feel like buying the Graphic Plus, which is the kind of harder one to find, then you can make one as well. There's also a clone of a 64K RAM expansion card for the Apple IIe, so if you are missing one of those, I'm assuming these are pretty cheap to buy, but I have no idea. Sometimes it might be missing from your IIe. Well, you can make one of these up and then get your machine up to 128K with double high res. I really want to thank Brad for his service to the Apple II community. It's really helpful to have all these cards available as fully open source projects that are easy to make because it's just all through-hole, so anyone can solder these together and all easy to get parts. Unfortunately, sellers these days might take all the cards out of an Apple II and sell those separately just to get extra money. So if you get yourself an Apple II Plus and everything's been taken out of it, you may need to get a bunch of extra cards like a language card, disk controller card, 80 column card, things like that. And well, the fact is with Brad's projects, if you have a little bit of soldering skills, just get the PCBs made up at PCB manufacturer and find the chips, and you should be able to make these really easily without spending much money at all. All right, moving on to packages that were mailed in. This one comes from Ryan in Coral Gables, Florida. Hi to all my Florida viewers. We have a little package here with a little letter and a sticker. Hi Adrian, longtime viewer, first time mail caller. I found you during the era of the human malware and instantly got hooked on your content. I distinctly remember your Mac Color Classic repair video in early 2021. I love the dedication and thoroughness of your approach in getting these old machines working again. Since then, I was inspired to work on my own retro project, and I ended up building a MIDI compatible synthesizer cartridge for the SNES. I've gone back and forth on whether or not it makes sense to send you one, since it's mostly something musicians would find useful, but I thought it might be a nice piece of curio for your collection. I think you have a MIDI keyboard handy, but if you don't, this unit or the unit is highly general MIDI level 1 and 2 compatible. So you can just run random MIDI files you find on the web into it and enjoy the results. Just remember that the SNES audio chip only has 8-voice polyphony. If you want to get fancy, some people use it as an external MIDI synth for retro systems like MS-DOS and Windows 95. And I believe some old LucasArts games output MIDI directly. Actually, I found this MIDI file format from the web, and I think you'd really like it. Thanks for all the hard work you put into making quality content, and many well wishes, Ryan Hunter. P.S. You can find more about this cartridge at this URL here, supermidipack.com, e.g. documentation and companion application. That's optional. If you just want to play MIDIs on it, it should work out of the box. Okay, so here's our cartridge for the SNES. It's got a little micro USB port. Let's zoom in a little bit. Micro USB port and in and out. So let's take a look at that website, see what exactly we need to do something with this. Super Midi Pack. Inside your SNES is a MIDI synthesizer waiting to be set free. $120 plus sales tax and shipping. Limited stock available. Here's contact information on there. Compatible with Super Famicom, NTSC, and PAL Super Nintendo Super NT. 16 polyphonic MIDI channels with independent settings, multiplexing over 8 voices. High degree of general MIDI level 1 and 2 compatibility, as was mentioned in the letter, and advanced MIDI features containing tuning, pitch bend sensitivity, master tuning. All SPC 700 DSP registers are directly writable via CC messages. I guess that means that your software that you're using to control the SNES through this, you can totally do whatever you need to do with the SPC 700. Now, as far as I'm aware, the SNES doesn't have any built-in instruments. It's entirely a wavetable synthesis type of DSP, which is why it's called a DSP. So I guess you have to load samples. They can be uploaded via web MIDI application, automatically converts from SPC, WAV, and SF2 formats. I guess that means you can take the instruments that are out of, well, tracks that are from the NES or Super NES already and use those as instruments with your MIDI creations. 3.5-inch TRS Type A MIDI interfaces. And the USB interface is galvanically isolated to prevent ground loop noise, so humming and stuff like that. That's kind of cool. And you can play existing SPC files. Firmware upgradable. Check documentation for list of features. There it is in a clear case. Cool. There are those TRS cables that come with it. I don't have those in the box, so not sure how to easily test this. Let's take out the documentation. USB cannot be used with another MIDI device unless it's MIDI host. Doing so may damage most devices. The two 3.5 TRS ports are MIDI ports that can be used with other MIDI devices. These are not audio ports, and it's important to note that both USB port and the pair of TRS ports provide equivalent functionality. Everything you can do with the USB port can be done with two TRS ports and vice versa. Okay, so some MIDI devices use traditional mini DIN instead of 3.5 TRS ports. To connect Super MIDI to these devices, you need an adapter such as this one. Let's take a look at what that is. Oh, that link doesn't work. So it's my assumption that the USB port that's on here just shows up as a MIDI device to your DAW, Digital Audio Workstation software. And it says if you are using the TRS MIDI ports to say external keyboard, to not use the USB connection. So I know very little about MIDI stuff, especially modern stuff with like USB ports. I've never done anything like that. I know about MIDI from the 80s and stuff from the early 90s. And even then it's very limited. I have a Roland sound canvas here that I barely know how to use. So I'm gonna do a little bit of a jump cut and try to figure this out. Well, I've been messing around with this for the last hour or so, and I unfortunately can't really get this to do much. The cartridge is working, as you can see there, and we can go into test mode and make sound. So the cartridge is fine. I'm connected via USB to my lab computer, and connected up you get a Super Midi Pak as a device under sound, video, game controllers. And this is the web interface that was mentioned in the documentation, and it does see it, no problem. It sees Super Midi Pak. Now, I was hoping that I could use this to play a MIDI file, because I don't have a digital audio workstation program on my computer, and I looked for an open source one. I went and downloaded one, but it seems to be one, but it doesn't really support MIDI devices. Now, this has a few options like upload SPC and convert MIDI to SPC. Ryan mentioned a file that I should try, which is this testfinal.mid. I downloaded it. Allows you to set up quantization, I guess some artist and names, and then it creates an output file, which I've already done this conversion because I've been trying it, and it makes an SPC. And if you try to upload the SPC to the Nintendo, we'll just do the one I just created, it spins, it blinks right here, and on the actual cartridge, there is a blinking LED. See at the top corner right there? But unfortunately, it doesn't seem to actually do anything. Even if we, okay, actually, all right, so it's defaulted configuration, which just goes blank, I think, to eliminate video noise that you normally would hear for the NES on the audio circuit. But what happens is that output thing here is blinking, Super Midi Pak, and the LED is blinking, and it doesn't seem to do anything beyond that. Sometimes it stops blinking, but I never hear any actual audio coming out of the Super NES. And it's not frozen or anything. I can push the controller and you know, access the menus, and we can go, oops, go to test mode. But now that it's taken control or whatever, there's no more audio. But it's almost like it's got no samples. Like it powers up with some samples in memory or loads them into the sound chip, and after that, it doesn't work. Sample directory, deselect all, add directory entry. This is all a little bit above my pay grade upload. I mean, it doesn't seem like I have any samples created here. I could figure I just upload one of these SPC files, like this is from Super Castlevania X. And if I double click on one of these, it does the spinny thing, and it will just sit here essentially forever. And that's even if I reset the console, start from scratch, it doesn't seem to ever actually do anything. I figured uploading the SPC would actually just play the music, but perhaps what it's doing is only uploading the instruments from the SPC file into the console. I guess I don't really fully understand it. Now looking at the web interface here, there are all sorts of other settings. I've got some global settings, a bunch of echo settings for all the different channels. These are all the registers inside the sound chip. Channel timings, whatever that does, and then each of these channel settings, I think they all look basically the same. Allow you to tweak these values, I think. Well, I don't know, it doesn't let me do anything. Maybe because there's no samples, or I suppose it's busy doing this. Whoa! Okay, well that one worked. Interesting, that actually played the music. That's the first time I've heard this thing do anything. I've tried to load a bunch of other SPC files and it will spin forever. But I guess there is an issue with the format of the files or something. Let's try this one. It takes a little while to upload. MIDI is pretty slow. It was designed just for note information, not sending large sample data. This is going to be sending, what, like 65 kilobytes of sample information across. That's how much RAM there is for this particular sound chip. Now, while this SPC file copies over, this should actually have more music than just a little intro tune. Oh, there it is. All right, well, that was working perfectly. Yeah, it's interesting. The SPC files I was trying before weren't compatible or something like that. Now, obviously, the use case of this would be you would connect this up to your digital audio workstation, your synthesizers, whatever. So you could use a MIDI external keyboard or production system to use the SNES as a synthesizer. And I know these types of carts exist for other systems like the regular NES, the Game Boy, so that you can create like 8-bit chip music using those consoles in your live concert productions up on stage. There you go. If you want to use your SNES as a synthesizer, the Super Midi Pak is for you. And I'm sorry I can't better demonstrate this because I am like the least musically inclined person there is. Incidentally, the MIDI file that Ryan recommended I download was the 8-Bit Dance Party song, which is the intro song to Donkey Kong Country, I think. I never had a Nintendo 64, so not 100% sure, but I know it comes from that game. And I guess it was a MIDI conversion, and then we tried to convert to SPC to then play on the Super NES with this cartridge. But like I said, that would just sort of not actually work, at least for me. And I couldn't figure out a way to easily play that MIDI file through the MIDI interface over USB into the cartridge using, say, like the general MIDI instruments that are loaded onto this, I'm assuming, at power up when you reset the console. You could obviously hook this thing up to your retro gaming machine as well using, of course, those MIDI breakout cables and then appropriate MPU 401 cable for your DOS PC, and then play games and stuff using general MIDI, like Doom, for instance, which should totally work on this. And that might be kind of cool, actually. Now, when it comes to the nostalgia for the sounds of these old consoles, I don't have a lot of nostalgia for the Super Nintendo. I have never had a Super Nintendo. This is actually my first Super Nintendo that I've ever had. Thank you to Big Steve, locally here in Portland, for giving this to me. My game console repertoire literally was an NES, which I got, you know, when that was contemporary. And then I didn't have any game consoles until the PlayStation. That was my next game console. And that really was because at the time of the Super NES and the Sega Genesis or Mega Drive, I was using my Commodore Amiga and my PC for gaming. And to me, I didn't really need to have the game console, although playing some of the games on the Super NES, there's amazing, amazing games on this thing. And same for the Mega Drive, there's really good games on there as well. But my gaming itch was really satisfied by the Amiga and my PC. So when it comes to like the sounds of the 90s for me, it's mod files all the way and all the tracked stuff that came with that. Not so much the soft kind of rolled off tones of the sound chip in the SNES. I know that a ton of people do have huge, huge nostalgia for this. And if you're a musician, being able to integrate a real NES into your production workflow and say, do a concert with a real NES using this cartridge, that sounds freaking awesome. So that's the Super Midi Pack. Turn your SNES into a synthesizer. So thank you, Ryan, for having found my videos during Human Malware and then coming up with the idea to make this cartridge and yeah, sending me one to check out. I'm sorry I couldn't demo it a little bit better. All right, next up we have a package from John and Christy in Boise, Idaho. Hi to all my Idaho viewers. Okay, we have a note and I think a bunch of RAM. The letter reads, here are the memory modules I emailed you about back in February. They were saved from old machines that I upgraded for capacity reasons, so while these will be on the smaller size, I expect they should be in good working order. Some of them are Micron memory, and I know you aren't a fan. Actually, really, it's just MT RAM, and that's the old stuff that is the problem. I know Micron, I think in MT, Micron Technology, same company, but the stuff that's later on memory modules, not a problem. And yeah, John goes on to say, by the time they started making these modules, the quality was much better. I've never had any problems with modern Micron memory ever, to be honest, always very reliable. As I worked for the company for many years, the employee discount made Micron memory my go-to choice. Okay, well, there we go. Yeah. I wonder if employees at Micron knew about their bad 4164 DRAM chips, but maybe they weren't failing back then, so that wasn't a problem. I also wanted to say I really enjoy your channels. I've been a software developer for most of my life, but I've had an interest in electronics. Learning from your videos, I have gained the confidence to attempt a repair or the repair of several items, saving me well over $1,000 so far. Thanks for all you do and keep up the great work. Regards, John. Thanks for the nice letter, John. So I think we just have a bunch of memory here. Let's just unbag this stuff. So I grouped all the RAM together into the same type. So we have 4 of these, I assume 4 megabytes. And then these modules here say 1024. So pretty sure that these are going to be 1 meg, 80 nanoseconds. For some reason we have 5 of these. And then these 3 modules, probably 1 megabyte as well. Oh, actually, there we go. We actually have 6 of these. 6 of those and 2 of those. Mag 1024. Very similar though with the M8 and the 1024, although Edge versus Mag. What's the difference? I don't know. And on the back of these modules, they certainly look like the exact same PCB and no markings. And then we have these 2 modules. So unlike the others, we see 44001, and that's because these chips are actually 4 bits wide. So 30-pin memory modules are 8 bits wide, so 2 of these chips for 8 bits. Now, as for the capacity, if this is a 4 meg module or 1 meg module, I'm not totally sure. We'll have to plug it into something to find out for sure. There's only 2 of these though, so good for 16-bit systems like 386SXs, and no parity memory on those. Although these, if you notice, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 memory chips, and these are 1 bit wide each, and that means this is parity memory. Most of the time, motherboards, once they went to Sims, didn't need the extra parity bit. I think on a lot of systems, it's just not even used, like on Macintoshes, for instance. And then we have 4 of these modules. Now these are parity modules. And the interesting thing is these are 41,000s there in the middle. These are the parity RAM chips that make this a 9-bit module. That's the parity bit. So these are going to be 44 something or other. It's really hard to read. Let's see if we can figure out how to read that marking. It's an IBM part number, an IBM used strange part number. So really no way to really know what the size is. But nice quality PCBs with gold contacts. Nothing on the back. Well, except for that, whatever that means. But yep, 4 parity memory modules. Now I've been collecting this type of memory for a while now, and I have a box that's just filled with it. I just put it all into an anti-static bag. And the intention is one day I'm gonna test this all. I really need to. And I like to go through all the RAM and test each one with the fancy RAM tester that I have. And it will tell me if it's a 1 megabyte module or not. Well, 1 or 4 or 16 potentially. It also tells me the speed. So it does some testing to see how fast it is, because sometimes it might be marked 80, but you know, might actually get more like 60 out of it. And potentially the really good performing RAM is great for overclocking perspective. So sometimes it can be worth separating that out. Now, should I be doing this RAM testing on my own at random times, or like while I watch a video or something like that? Maybe. But I've sort of thought about doing a live stream. Now, just as a side note, I do occasional live streams. It's to my higher tier Patreons and YouTube members. So the $4 tier or 4-bit tier and up gets access to those live streams. I think I've done like 3 or 4 of them so far. And yeah, if you want to become a patron, they are accessible and watchable at any time. Unfortunately, YouTube has this terrible habit that when you clip the live stream videos, like of course I've archived it and saved it into my channel. When I edit off part of the video, like the first part I cut it off usually because it's just like a standby screen, what happens is all the live chat gets lost. So I kind of need to stop doing that. But anyways, yeah, if you're interested in those live streams and you're a patron or a YouTube member, definitely let me know. Oh, just as a side note, by the way, as well, YouTube members, I'm not sure you know that I post all the early access stuff on my channel's community section. So there's community section with posts, and in there are posts of all the early access videos and things like live streams and other behind the scenes videos, so the higher tiers. And I'm not sure people know about that. I don't think YouTube really notifies members when I post stuff there, and therefore you may not even know that those are there. So if you're one of my YouTube members, please go take a look at the community section. Maybe there's a way you can turn on the notifications for when I do post stuff there, or just periodically check if you want to see early access videos. Anyhow, thank you very much, John, for the memory. This will be going into my stash of RAM for future testing. And since this was a short one, let me grab another little box. Okay, next up, this says it comes from Blue Shell 3D in Austin, Texas. Hi to all my Texas viewers. Okay, in here it looks like we have some 3D printed stuff. What is this? Oh, this appears to be an NES front loader replacement mechanism, and it's 3D freaking printed. How freaking cool is that? I had no clue that this was a thing. And it has a new PCB here for the 2 cartridge connector. So this is the one that goes onto the PCB, the main motherboard of the console, and the cartridges plug into this. My assumption is this is far more robust than the original Nintendo one, which is all kind of flimsy. And if you look at the back, it doesn't have a PCB, it just has contacts and things like that. Okay, I think I get what's going on here. Do not press down. So I think what goes on is you open the front of the console and you just slide the cartridge straight in with no down mechanism. This, besides the do not press down one, we have this, which I guess is the same part. And then here is the installation guide. If the NES blinks upon startup, press the reset button 4 to 8 times in succession to set the CIC bypass to the correct region. The Nintendrawer. Inside the box, this shipping label was there. I'm just covering up the address. There's no original name on this, so I don't know if this was sent to me from the people who developed this, or if one of my supporters or viewers purchased this and had it sent to me. Nintendrawer nameplates, do not press black, and then the Nintendrawer for the NES 72-pin connector replacement pre-order. And I'm just taking a look at the way this is designed. There's a flat flex ribbon that goes between this upper PCB and the lower one. That's kind of fascinating. All right, and I can see that this is the part here where this do not press down goes. So you can either have a blank without any printing there, you can have the name of the product, or do not press down. Looking down on the back, Nintendrawer, you can see it there. This part does move. So here is an NES cartridge. Just seeing how this might work. I have to go read the instructions, obviously. So that clicks in, removing the cartridge. Is that what's supposed to happen? It stretches the flat flex, I guess, right? And then you just pull once it hits the stops there. Let's just give that a try. And it pops out. I wonder if that's gonna wear out this flat flex over time though. Looks like for installation, take the console apart, remove the shielding, remove the retaining screws to remove the push down tray, remove the stock 72-pin connector. Looks like the one in their photo has a little bit of damage on it, or could be the reflection. Install the Nintendrawer. It'll slot right into where the 72-pin connector was just removed. The easiest way is to slide the drawer forward so you can see the 72 pins of the main board on the Nintendrawer. When doing this step, make sure the lower RF shield's out of the way. Well, this console, I just brought out one of my NES consoles right here. This doesn't even have an RF shield anymore. And test the console, clean the cartridge. If you're seeing blinking red lights, okay, well, I've disabled the lockout chip, so that's not going to happen. Please note, there are 2 extra screws that will be left over and 2 silver screws that held down the old 72-pin connector. Also, take care not to over-tighten the screws. All units are 100% tested prior to shipping. Is the Nintendrawer compatible with the Game Genie? No. Game Genie PCB is extremely thick and potentially damage the slot of the Nintendrawer. We are working on it. Well, that's all it really says. So my assumption is that this works exactly like I thought it does. So this pulls forward and reaches the stops, and you pull the cartridge out, and then as you push it in, it pushes it back like that. And it does kind of lock in place in that position. I think it's locking into position because there are magnets right there that hold on to these screws. So it actually captures it. See, it's not moving now. I mean, it pulls forward easily enough. I also notice there's a small IC. So I wonder if that chip does some lockout disabling. Also notice that you can remove this flat flex. So theoretically, I guess if that wears out over time, which I could see it being a wear item, but maybe not. I don't know. You could change out just this top part, I suppose. All right, let's take apart this NES. This was one that I assembled from loose parts, let's just say. So the screws aren't even the right screws for the console. This thing was just hodgepodge. Now, I think I actually have enough parts to build another NES. Sorry, it's all out of focus. Like, I have another case, and I definitely have another motherboard, but I think what I was missing was this mechanism. And that's kind of cool. It means I think I can make one more console. Okay, so the screws are going to fall out, maybe. Yep, there we go. Okay. Oh, that screw is still installed. Like I said, these are just random screws. Look at this. This one's silver and different lengths. I just tried to find stuff that seemed to work. This is a very easy installation. Obviously, if you have the shielding installed, it's a little bit more difficult. Let's hope that these screws that are holding this down are going to be long enough to work with the Nintendrawer. Okay, to fully remove this, you do need to take out all the screws on the motherboard because you have to lift it out of the case a little bit. So I have a couple around the RF shield because there's things you plug in there and that adds extra stress into that area. That cap looks a little bit bulged. So once you lift the board up a little, then you can just slide this out. And this goes backwards like that. So this is the original mechanism, and you'll notice the way that connector looks. It's not only at an angle, but it's kind of got a wider opening because that allows the cartridge to pivot in there. This is one common area on the NES that's a problem. It's not gold plated, so you might need to put a little bit of Deoxit on there. Should be able to push this forwards. Okay, there we go, it's on there. Right, the NES is back together, at least the bottom part, as far as it will go. Let's test this out. So you slide this in. You will have to hold the console when you insert a cartridge just because it actually will push it that direction. And when you pull it out, kind of the same thing. So you pull, there we go. And that kind of flops around a little bit. And if we take the lid and we put this on, not working. What's happening is this structure here sort of hitting this. Okay, I think I got it. Maybe. There we go. Yes. So just go straight in. Oh, look at that. And then this will close, no problem. To be honest, I'll just put a sticker that says do not push down right in this area. And then to get this out, it is a little difficult. Sorry, it's a bit hard to see. You have to kind of reach in, pull this out. I mean, remember the magnet holds it in. See, well, okay, still goes forward. But if it's sitting on your desk, you just pull it forward ever so slightly. There's the cartridge. It's still actually connected. You could run the console this way. And you just pull this out. There we go. How cool. That's really clever. Impressed. I'll get this clone cartridge out. Stick this EverDrive one in. It's just weird not pushing down. It's just a lifetime of muscle memory pushing that down. And we can load something like Super Mario Bros. 3. Or sorry, 1. Oh, looks like we have a bad connection on the video cable. That's odd. Oh, I just touched the RetroTink and we lost signal there. Wonder if this is a problem with the power bank here. Okay, yeah, I think it's just a bad connection on the power connector. All right, that seems a bit better, doesn't it? It's obviously working. And again, it's weird that you can pull the cartridge forward and it still works. So it feels a little loosey-goosey. My only observation was maybe the magnet should be a little bit stronger on the cartridge because just moving it forward a little bit kind of flops forward. So maybe if those magnets held it a little more strongly. Now, obviously it's working with this clone EverDrive here. pull this out. That wasn't too hard to insert. Let's try this also cheap cartridge. Turn that on. Yeah, that's working fine as well. For a 140-in-1 type cartridge, I don't know where I think I got this AliExpress or whatever. It's quite good, this one, because it doesn't have any repeats. This looks just like the Commodore 64 version of this game, which is kind of interesting. You do have more buttons though, so you have a separate jump from fire. You don't have to push up to fire. Pushing up doesn't do anything with this game. Oops. That's pretty nice, but it pretty much operates exactly like the Commodore 64 one, and it looks very similar how the background is just a solid blue as well. Not sure why this is called Super Turrican, because isn't that the name on the Super NES version of this game as well? Or maybe that's Super Turrican 2. And we have one more game to try, and that's an original Duck Hunt and Mario Brothers game. That was a little harder to push in actually than these clone ones, but as you can see, working just fine. And incidentally, it's very difficult to play games through OBS capture. You'd want to split the signal and be playing off the direct signal from the console. I am watching this through OBS on my computer screen. There is a lot of delay. Yeah, like right there. Yeah, anyways. Well, I have to say, that is freaking cool. I'm pretty stoked by this. This NES, this particular one I just installed this into, I'm going to make this sort of my pimped out one. So this is going to get the PPU Copper Dragon digitizer. So this will have HDMI quality output via the RF jack. It says Lumicode on here. This may already have that installed. I can't remember, to be honest. It must be installed actually. So we didn't need to look at that through the composite capture. That's pretty hilarious, to be honest. I think I need to do a few upgrades to the RF modulator circuit that's in here. Maybe replace that cap that was bulging a little bit and just clean up the signal. I think Mark over the Retro channel had a few mods you could do to the RF modulator on this to bypass some of the circuitry we don't need anymore to make it where the audio has less buzz in it. The audio on these types of front loaders have a bit of buzz in them, and just because it's picking up some of the noise from the video circuitry or the video signal. So a little bit of a bypass with some coaxial wire inside the RF modulator, or maybe on the main board as well, does quite a bit to make the audio a lot cleaner. Now what's cool is I have these as extras, so I could put together another front loader. A lot of people say that they have problems with their, with this thing, and they end up buying new, replacement ones. But I gotta tell you, I have maybe 3 or 4 NESs, all front loaders with this original connector, and I don't have any issues. And the reason why is A, I've disabled the lockout chip, but that wasn't really the main fix. The main fix was just putting Deoxit on all of the pins, both the top and the bottom, putting that on, and then with the Deoxit on there, just plug the cartridge in and out a few times, and literally your problems will go away. You will not have any more issues. I mean, if you did, you could just spray a little bit more Deoxit in there. These NESs, when I got them, they didn't work at all, which is why they were all disassembled, because they were going to be recycled because they were broken, supposedly. But the reality was, Deoxit in this is totally what brought them back to life. But if you don't want to go through that, or you just want more stability, then potentially this Nintendrawer solution is a bit more robust. Because if you think about it, this is much more like the top loader, where the cartridge just physically plugs into a connector and it doesn't have the wiggle and the up and down or any of that stuff. So this should be more reliable. I think the only thing that I would worry about is that flat flex cable over time potentially breaking. A quick Google search brought me to the Nintendrawer NES 72-pin connector replacement, so that's what's installed in here now. $55 US. It does come in various colors. Pretty cool if you have a clear case replacement for your front loader and you get one of these, it jazzes up a little bit. Now noticing here it says pre-orders for Nintendrawer Mark II will begin March 21st, which has just passed. Now, it does appear that I've had this package, looking at the box here, since August of last year. So I apologize to whoever sent this in. It has been here a while. I'm not sure how it's going to change versus the original version, which I'm assuming is what this one is. It brings top loader compatibility to the NES-001 aka toaster, or front loader, I like to call it, while maintaining the OEM look and feel you expect. And it does say here, has custom electronics and lockout bypass chip for improved compatibility and region-free gaming. A pretty nice solution if you don't feel like cutting the pin on the lockout chip like I've done on all of these consoles. Someone mentioned in a recent video where I talked about doing that cutting that pin can cause some compatibility issues with certain games, or other instability issues. I have to say I have certainly never run into any problems, and I've had that cut on all my NESs for quite a while. But on the other hand, I don't have any games that try to bypass the lockout chip, like the unauthorized third-party games, which I think do some trickery to try to do it. I don't know what those are going to do. I think there's a thread somewhere on the internet that has a more comprehensive way to bypass the chip. It involves like some bodge wires and lifting some pins and things like that. If you're wondering why you can't just take the NES lockout chip out of the motherboard entirely and just do away with it, you can't do that because it's handling the reset for the entire motherboard. So if you remove it, the system won't work properly because it basically handles the reset. It also handles the power LED on the front, which is why when it detects an issue with the game you're using, it will flash the LED and put the console constantly into reset and out of reset. If you don't want to make a modification to your original main board, all you have to do is get one of these things and it will just bypass it anyways. Plus it make it just the whole thing more reliable. Pretty sweet. Looks like this is also available on Etsy by Rocker Gaming. Oh, and look at that. There is a clear case. And yeah, with the color version of the 3D print, it looks super awesome. I'm kind of a sucker for these crystal clear cases, although I really like the original look of the front loader. Yeah, I'm trying to get that in camera. I just took a quick look through my email to see if there was anything that I could quickly find from viewers or supporters about sending this particular product to me, but I couldn't find it. So to whichever viewer who sent this in, if you're watching right now, I really very much appreciate it. And I have to say I'm very impressed with this product. It's really creative and I think it's a lot nicer than the replica, these things that you can buy. It's probably a little bit more expensive, but you're probably going to end up with a more reliable console, especially because it has the CIC bypass without you having to cut anything. And that alone is probably worth it to a lot of people. Okay, that is going to be it for this video. I want to thank everyone who sent stuff in. That would be John, the mystery viewer / supporter for the NES mod, Brad for the Super Serial card, Jerry for that ROM emulator, and Ryan for the awesome Super Midi Pak for the Super NES. It's kind of funny, I never really know where these videos are going to go. I just open stuff, and 2 of the things I opened in this video were Nintendo console related things. Yeah, kind of amusing. Anyhow, thank you to everyone again, and if you send stuff in and you haven't seen it yet, don't worry, it's going to happen. As you saw, that one thing was from August. That's just how it goes. Stuff is very backlogged here in the basement. And a huge thanks to my supporters. Names are going up the side of the screen to make it possible to do this full time. You can become a supporter down below, and you know, all the usual YouTube junk if you liked it, thumbs up, etc., etc. And that's going to be that. So stay healthy, stay safe. I'll see you next time. Bye.